Okay, I'm going to talk about section 10.6, chapter 10, gas law mixtures and partial pressures. Alright, in a mixture of gases, what I can say is that the moles total is equal to the sum of all the moles in it. So this is section 10.6. Okay, so if I look for the moles total, that's equal to moles 1 plus moles 2 plus moles 3, and however many different gases you have in the mixture, all the moles are going to total up. Okay, if you look at PV equals nRT, okay, for any specific gas, I can say the pressure of gas 1 would equal the number of moles of gas 1 in it. It could be 2, 2, 3, 3, or I could say the moles total, the pressure total, is in a number of moles total. So pressure and moles are in direct proportion to each other. So I can come up with Dalton's law. Okay, and Dalton's law of partial pressures. So remember, a partial pressure is just the pressure exerted by one specific gas in a mixture. So Dalton's law of partial pressure says this: since the moles total up, the pressures total up. Pressure total is equal to P1 plus P2 plus P3, etc. So that's pretty easy. If I look at the pressure of air, it's equal to the sum of the pressure of the nitrogen plus the pressure of the oxygen plus the pressure of any carbon dioxide. Maybe we have some argon, and maybe we have water, and it would be all those different gases add up to your total air pressure. Most of the time we look at Dalton's partial pressure when we're collecting gases over water. So if I was collecting like carbon dioxide over water, some of the water in the surface of the water would get in and mix with the gas. So if there's any moisture in your gas, you have to account for the vapor pressure of water, because that's going to be part of the total pressure of the air. Okay. Now, what we get into then is mole fraction, and that just means the fraction of moles of a specific gas. So mole fraction would be the moles of gas A over the moles total. Now if you see the problems we have, if you ever have grams of nitrogen, grams of oxygen, grams of carbon dioxide, the first step you would always do to figure out mole fraction is to convert grams to moles for each specific one. Then you total them up, you take the partial out of the total, and I'll do an example of mole fraction for you. And the last thing I can say is that you then can have a law where if I say, well, the pressure of A is equal to the mole fraction of A times the pressure total. That really comes from PV equals nRT. If I take PV equals nRT, and I'm talking about A and A, and I divide that through by PV equals nRT, and I'm talking about the total and the total, assuming that the volume, the R is constant and the temperature is constant, I would then get pressure of A over pressure total equals moles of A over moles of total, and then rearranging that, pressure of A multiplying both sides by P of T would equal the number of moles of A, the mole fraction, which would be the A over the total times pressure total. And that's how that law is derived. If you're doing gas laws, you could do it two different ways. You could do a different pressure for every gas. Gas 1, gas 2, gas 3, gas 4. And then you can just total up all the pressures to get the total. Or you could sum up the moles and then just plug the total in and get the total pressure out at the end. So that's Dalton's law, and I'm going to stop right there.